Brighton seafront with the Nikon P510. Have you seen that video?
Possibly. Remind me what's in it.
Well, it's a guy who apparently he's a PhD. He has a PhD in spectrophotometry, which I had to Google that. It says spectrophotometry is a method to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through sample solution. So this guy has a PhD in that, and so he knows the light, right, and all its mechanics pretty well. So he was a glober who heard about flat Earth and all these things, and people, doing laser tests. So he himself wanted to go out and do the experiment, and he used all sort of measurements. He took temperatures and everything. So he did about a 13.5 mile observation, and I mean, I can ruin the ending for you if you want. Otherwise, you can watch it. But
No. It doesn't matter about spoilers. Just tell us the outcome.
So he compares three models. He compares I don't remember what he calls it all, but he compares a flat Earth model versus a globe model versus a third model is a globe model with extreme weather conditions, right, to account for extreme refraction, extreme distortion due to the atmosphere, etc. Out of the three, he says the only model that works is the flat Earth model.
Ha! Nice.
Yeah, I'm surprised you guys haven't seen it. It's being shared all over, and it's being.
Give us a link, man.
Okay.
Bring that link. That's awesome. I thought you were gonna go in a totally different direction and say it's a new glober who is saying, "Oh, we have proof that the sun is a physical object. Look at, I'm analyzing the light," presupposing that that light is actually physical, or originating from a physical for which they have no proof in the first place. Reification fallacy. Right, Nathan? Because they can do that. If you can analyze material through light, and you can actually confirm that that material is that material, yeah, it works. But if you're just gonna apply it to some light, then that doesn't necessarily have to prove that it is made of that material. That may be one of the options, but you have to physically confirm it. Otherwise, you would just be presupposing that it is material. Correct, Nathan?
I think he's looking at the video.
Basically,
it's a really long video. It's an hour and 40 minutes, and I didn't, sit through every minute of it, but I sort of scrolled through it, and I read all the slides. And the beginning, if you want to just watch the beginning on your own, it does tell us who he is, why he's doing it, the method used, all that. And then, of course, you can jump to the end and see the conclusion of the three models he compares. But he goes into a lot of detail. He uses a lot of math. There was a couple other people that had some academic credentials who also worked on this with him, probably to get the maths right and all that, and angles and everything. But he did a really thorough analysis. One of the cool things in that part of the video you showed, just there for a second, he used what I think he called a viewing tube. So he had like this long, maybe 8-foot tube where the camera goes into right at the end of the tube, so it prevents extra light from hitting the sides of the camera. So it reduces the amount of light that the camera sees to help with like refraction and all that. So there he's talking about all the distortion that's possible, but that wasn't seen in his experiment. And he's basically
the interference.
Yeah, and the
interference, lens flaring, all that.
Right, and he's talking about there are scenarios where light bends up, where it bends down, and I'm just reading here. How globers always say, "Oh, well, it's refraction because it's bending down." He says this guy is saying that over sea light doesn't bend down; it only will bend up. He's like, so it's not possible even for it to bend down. In other words, bend over the curve. He's like, I don't know any documented examples of that even ever happening, which is why he says if you do an observation over water, that's a non-factor. He says the only factor is light going up, like we've seen those videos of the lasers where at the end the light shoots up like towards the sky. He goes, then you have to take that into account, but not the downward refraction.
Well, it's a different kind of refraction. You have actual refraction, which you can physically prove, although it is most obvious with a medium change from solid to gas or liquid. That's when refraction is really obvious. It still does happen in the form of diffusing, but the refraction that the ballers refer to is an imaginary construct, an R-based construct that suggests that light literally bends in an R-based fashion around a corner. And that is just a total science fiction made up concept. It's nothing like the real refraction. It's just a made up thing.
Yeah, an arbitrary 7/6 R height to bend light around.